Good morning, everyone. Today I'm going to explain one of the topic in pedal triangle and its properties. So, pedal triangle and its properties. First of all, I'm discussing what is the actual definition of a pedal triangle. After that, first actual definition of pedal triangle, and next one is distance between vertex A to orthocenter. So after the distance between orthocenters to foot of altitude, after that angles in a pedal triangle, after that length of sides, in pedal triangle, after that area of triangle in pedal triangle. Area of triangle in pedal triangle. So these concepts I'll discuss. Let us see. So what is the actual definition of pedal triangle is nothing but in a triangle ABC, so a triangle formed by the line joining the foot of altitude. This is nothing but foot of altitude. AD, BE, CF, a triangle. This is nothing but joining FD, DE, FE. This is nothing but pedal triangle. Triangle DEF is nothing but pedal triangle. So what is the actual definition of pedal triangle? A triangle formed by the line joining foot of altitude is called pedal triangle. Once again, a triangle formed by the line joining foot of altitude is called pedal triangle of given triangle ABC. See, so now I am discussing what is the distance between vertex A to H. So let us draw big triangle ABC. See here, AD is the foot of altitude, makes 90 degrees. In this foot of altitude, here is B. This angle is 90 degrees. This angle is B. What about this angle? 90 minus B. Similarly, here is 90 minus C. Similarly, again one more foot of altitude BE. So what about this angle is makes 90 degrees. This angle is 90. This angle is A. What about this angle? 90 minus A. Similarly, this angle is 90 degrees. This angle is C. What about this angle? 90 minus C. Similarly, again one more line, foot of altitude. B, AD, yeah. Okay. Here also, this angle is A, this angle is 90 degrees. This is 90 minus, this angle is A 90 minus A. This angle is C 90 degrees. Here is 90 minus B. Okay. In this, I'm discussing first distance between vertex A to H. In this, I'm taking this part only here. Here is a orthocenter H. Here is the orthocenter H. A, H, B. Joining these, here is 90 minus A. Sorry, 90 minus B. Here is 90 minus A. Here is A plus B. In this here is in this side is small a units, small b units, small c units. This side is small c. See what about the sine rule here? Ah by opposite side, by sine by sine 90 minus a is equals to ab by sine a plus b. AH by cos A is equals to AB by AB is nothing but side C. So in place of AB side, write small c units by sine A plus B. AH is equals to C cos A by, here is sine A plus B is nothing but sine C. Why? Because A plus B plus C is 180 degrees. A plus B is equals to 180 minus C. Applies sine, you get sine C. AH is equals to C by sine C into cos A. C by sine C is nothing but from sine rule 2r cos A. AH is 2r cos A. Similarly, AH is 2r cos A. Similarly, BH is 2r cos B. CH is 2r cos C, where R is a circumradius of given triangle ABC. Where R is a circumradius of given triangle ABC. Now I am discussing one more, distance between orthocenter to foot of altitude. Second one, distance between orthocenter to foot of altitude. Orthocenter to foot of altitude. See HD. HD, you are asking to find HD and HE and HF. Now I am discussing HD. Take these two triangles, what we have to observe. This is a one triangle HDA, HDB, and one more triangle here also, HDC. This is 90 minus B. In this angle is 90 minus C. 90 minus C. See here, cot I am taking, cot 90 minus C is equals to dP by dH. Similarly, cot 90 minus B is equals to dC by dH. Tan C is equals to dB by dH. dB is equals to dH tan C. Similarly, dC is equals to dH tan B. From adding these two equations, BD plus DC is equals to DH, take common, tan B plus tan C. DH, BD plus DC is nothing but BC. Total distance is small a. Tan B, can I write sin B by cos B plus sin C by cos C. Take the LCM is cos B cos C. DH times of cos B cos C, sin B cos C plus sin C cos B. That is equals to DH times of sin B plus C by cos B cos C. So here A by, here that is nothing but A. A by DH is equals to sin B plus C is nothing but sin C by cos B cos C. So A DH is nothing but A by sin C into cos B cos C. So A by sin C is nothing but 2R cos B cos C. DH is nothing but 2R cos B cos C. 2R cos B cos C. Similarly, in this HD, HE 2R cos A cos C. HF 2R cos A cos B. Similarly, Next point is angles in a pedal triangle. Next, third one, angles in a pedal triangle. So what is the angles in a pedal triangle? See here, in triangle ABC, AD is a foot of altitude, BE is a foot of altitude, CF is a foot of altitude. Here is I'm taking, here is 90 minus A, 90 minus C, 90 minus A, 90 minus B, 90 minus B, 90 minus C. Very clearly, see, here is the orthocenter. So observe clearly, this is nothing but, here is H, F, H after E, sorry, here is H after E, HE, here is C, here is D. This is cyclic. These are cyclic quadrilateral in this. And one more also observe clearly. F, H, D, B. Here also cyclic. Cyclic is nothing but, in this observe clearly, sum of the opposite angles is 90. Here is sum of the opposite angles is 90. D and F, sum of the opposite angles is 90. Here also sum of the opposite angles is 90. Sum of the opposite angles is 90. So you know this angle subtended theorem is angle subtended theorem in circle. So in this I am observing here angle FDE is nothing but angle FDH plus angle EDH. So that is nothing but 90 minus A plus 90 minus A. That is 180 minus 2A. That is 5 minus 2A. So in this triangle FDE, here is nothing but pi minus 2A, pi minus 2B, pi minus 2C. Pi minus 2A, pi minus 2B, pi minus 2C. That angles in a pedal triangle. Now discuss last one more point. Length of, one more property, length of sides of a pedal triangle. Length of sides of a pedal triangle. See, this is a pedal, this is pedal triangle. You are asking to find FE length and FD length and DE length. See, let us see here. AFE, I'm taking AFE. Here is angle A, here is supposed to angle C. Okay, so what is the sine rule? EF by sine A is equals to EF by sine A is equals to AE by sine C. EF opposite angle sine A, AE opposite angle sine C. Simply here EF is equals to AE into sine A by sine C. That is equation 1 you have to take. And one more, observe clearly here. A, this is a right angle triangle. A, E, H, AEH. So you know already I proved previous HE is equals to 2R cos A cos C. Okay. So in this I am taking, here is 90 minus C. So tan 90 minus C, I am observing clearly, tan 90 minus C is equals to HE by A. Cot C is equals to HE by A. That implies cot C is equals to HE is nothing but 2R cos A cos C by A 2r cos A cos C by AE. What about AE? AE is nothing but 2r cos A cos C by cot C. 2r cos A cos C into sin C by cos C. That is 2r cos A sin C. AE. Substituting AE value in equation 1, we get EF value or FE. That is equals to 2r cos A sin C into sin A by sin C. Sin C cancel. 2r sin A right bracket after cos A. That is nothing but small a cos A. So this length is EF length is EF length is small a cos A, and AE length is EF length after FD length. FD length is B cos B, and DE length is C cos C. Okay, now let us discuss one more area of the pedal triangle. Area of pedal triangle. Area of pedal triangle, you know that delta dash is equals to half BC sin A. So you know that half into here in this pedal triangle, this length is, here is F D E, this length is A cos A, B cos B, C cos C. This angle is pi minus 2C, pi minus 2B, pi minus 2A. Okay. This is nothing but small a, small b, small c. Let us consider small b is A cos C. A cos A, B cos B into sine pi minus 2A. A is nothing but 2C. Pi minus 2C. A angle. Okay. C of AB cos A cos B sine 180 minus 2C sine 2C sine 2C of AB cos A cos B into 2 sine C cos C. So delta dash is equals to of AB sine C, right in bracket, into 2 cos A cos B cos C. This is nothing but delta. Delta dash is equals to delta into 2 cos A cos B cos C. Delta dash by delta is equals to 2 cos A cos B cos C by 1. That is the area of pedal triangle. So now circumradius of a pedal triangle. Circumradius of a pedal triangle. Supposed to say circumradius capital R dash is equals to A by 2 sine A. Side 2 sine opposite angles. A is nothing but opposite angles. So that is nothing but A cos A. That is A cos A by 2 sine 2A. A cos A by 2 sine A cos A. Cos A cancel. 2 into 2. A by 4 sine A. That is equals to 1 by 4 into A by sine A. 1 by 4 into 2R. R dash is equals to 2 1s are 2 2s are. So simply R dash is equals to R by 2. So pedal triangle of circumradius is equals to half of the circumradius of given triangle ABC. Okay, thank you.